Hello, today we'll be talking about free radical substitution. What is a free radical, you may ask? A free radical is something that has an unpaired electron. And typically we see it in Cl2 and Br2. And they are formed through homolytic fission. This is when each electron goes to one of the molecules. So, for example, in CO2, it's Cl and Cl. It becomes Cl radical plus Cl radical. Same thing goes for bromine. It's Br, Br. Now when the bond breaks, it becomes bromine radical plus bromine radical. Now, these radicals are typically very reactive, so the reaction that first occurs is initiation, which we basically just saw right now. There's 3 steps to free radical substitution. The first one, initiation, is the forming of a free radical. And I'll be going through an example for the chlorination of methane. So for that, we would have chlorine, Cl2, just as we saw before. It becomes Cl radical plus Cl radical. Now, how are these usually formed? They're usually formed under UV light. Okay, great. Now we have our radical. The second step would be propagation. And what happens is in propagation is propagation is that you have your radicals react with your stable molecules. In this example, we have methane. Okay, so there's typically more than one step to propagation, so we'll go through that right now. It starts off with methane and your chlorine radical. Now, this chlorine is eager to become stable, so it will take one of the hydrogens from the methane, which will leave methane with one less hydrogen. That means it'll become CH3, or a methyl radical. Now, Cl, now that it has the hydrogen, becomes HCl. Now, as I said, there's usually more than one propagation. So the second step would be to get this radical and chlorine. And this would form CH3Cl plus Cl radical. As you can see, this broke off homolytically. And yeah, final step is termination. Now this is when the radical becomes stable. Now, as we can see here, we have this radical and we have this radical. So there's 3 different ways we could terminate. First way, Cl radical plus Cl radical, which goes right back to chlorine. It's basically the opposite of initiation. And then we can do the same thing with the CH3, the methyl radical, CH3 plus CH3, which forms C2H6. As you can see, they both are stable molecules. Finally, you could also do a methyl radical plus a chlorine radical to get CH3Cl. Now, this is a practice question, and since we've just done it, which is a propagation step in the chlorination of methane? Well, we know that it should be this one. And here, let's do a practice question. It says bromo trifluoromethane is used in fire extinguishers in aircraft. Now the question, write an equation for each of the following steps in the mechanisms for the reaction of CHF3 with Br2. Now, the initiation step is definitely the easiest. We have bromine, and we know that to make the radical, we go from Br2 to Br plus Br, not forgetting that it's a radical. Secondly, our first propagation step, we know to use our radical that we just created under UV light, and we typically use the product that's given, the reactant that's given. And this will, we know that the hydrogen always gets taken by the free radical, so we know it will be HBr, and that leaves us with a CF3 radical. Now, we always start off with the radical, we add bromine, and that leaves us with CBrF3 plus Br radical. Now to terminate this is pretty simple. We can do any termination step. My favorite one is the simplest one, the opposite of the initiation. So Br plus Br to get Br2. State one condition necessary. As stated before, it's UV light. And the last bit, draw an appropriate displayed formula in the space below. So we've done this. It's just gonna be CF3, and we have to make sure to include the radical. So that's pretty much it for free radical substitution. Thank you for watching.